In the world of computing technology, NCR has defined the future. NCR offers a wide range of compatible open products to provide from the most personal of computing needs to the needs of the largest enterprises. All NCR products depend on surface mount technology. Fine pitch technology requires specialized equipment, like the robotic general placement machine to ensure high-quality assembly of high pin count 25mm lead pitch devices. Computer vision and touchless centering techniques are incorporated in the automated system. This process ensures quality levels previously unattainable by either manual assembly or through the use of prior generations of assembly equipment. NCR recognizes the need to further advance this key technology. It takes vision, it takes people, and it takes commitment to attain technological leadership. NCR has formed a corporate manufacturing technology research center in Columbia, South Carolina to advance electronic assembly, specifically the interconnect technology. Deep science is required to advance surface mount techniques in order to assemble finer pitch, higher lead count devices needed by NCR products. Due to the increasing rate of sophistication in electronic assembly, NCR has gathered a few good men and women to advance interconnect and material technology. This team of chemists, metallurgists, and engineers are dedicated to taking NCR and our industry into the electronic assembly future. Many NCR products require the assembly of very large ASIC devices. Plastic quad flat packs, or tab packages with more than 200 leads spaced less than 21/1000ths of an inch apart, can be employed to house these ASICs. To reliably assemble such packages, advanced techniques are required. A new process called hot bar bonding has been developed to assemble devices that use these packages. The Manufacturing Technology Research Center cooperated with an equipment supplier to develop this process. With access to the base technology, the Research Center employed its scientific and analytical expertise to mold that technology into a usable process. This strategic partnering has resulted in a hot bar process that has been proven capable of assembling parts with leads as close together as 8/1000ths of an inch. Each lead is about the thickness of a human hair. The hot bar process and partnership proved to be so successful that the NCR Columbia manufacturing facility purchased a production hot bar bonder and placed it in one of its SMT lines. The bonder is assembling 0.5mm pitch parts today, with the capability to assemble parts with pitches down to 0.1mm. The capability to assemble ultra-fine pitch tab with hot bar additionally enables multi-chip module assemblies to be designed and assembled by the Research Center. This technology results in very compact chip assemblies, which generally, due to speed requirements, must be very densely mounted. Multi-chip modules will allow for processor cache implementations at 100 MHz and beyond, and will enable single package offerings of powerful functionality, such as this FDDI submodule. The tab bonds on this module are spaced at 0.3mm, or less than 12/1000ths of an inch. Another approach to ultra-fine pitch outer lead bonding employs laser technology. The Manufacturing Technology Research Center cooperated with a leading Japanese equipment supplier to investigate laser bonding technology. The bonder uses a YAG laser capable of providing 100 watts of power to reflow the solder joint. Laser bonding is rich with potential. However, further work will be required to refine it into a reliable process. Solder technology is evolving at an amazing rate. Complete understanding of the roles of oxides and intermetallics is mandatory to ensure high-quality microscopic joints. Additionally, the process of cleaning solder joints with chlorinated solvents, including CFCs, must be quickly replaced to preserve the ozone layer. This is a difficult problem. Powerful chemistry is needed to ensure a proper joint, but powerful solvents will not be available to remove these chemicals after the joint is formed. The Manufacturing Technology Research Center has personnel and equipment to address this critical area. Inorganic chemists and metallurgists employ metallographic techniques, scanning electron microscopy, X-ray identification techniques, destructive lead pulling, and ion chromatography to fully understand solder dynamics. This focused talent is allowing NCR to quickly adopt water-soluble and no-clean soldering methods. CFC usage in electronic assembly will be eliminated by the end of 1992 in all NCR plants, years ahead of the target date of the year 2000 established by the Global Montreal Protocol. Microscopic assembly requires in-depth knowledge of materials. No longer are joints formed by adding relatively large volumes of solder through wave or screening techniques. Micro joints are dependent on pre-deposited volumes and require flat surfaces to ensure reliable placement and assembly. As the level of integration increases in both the high and low-end products, substrate materials will become a more critical element in the product design. High-performance products require that ASICs and processors communicate at frequencies above 100 megahertz. Special low dielectric materials such as this 16-layer cyanate ester Teflon board will be required. Low-end product functionality will be integrated onto a single chip, which will allow the use of very low-cost substrate materials such as polyester. Electrically active polymers can replace solder to interconnect low-cost materials to other substrates, such as PCBs or glass. The Manufacturing Technology Research Center, in cooperation with Microelectronics and Computer Technology Corporation, is actively developing processes that will permit these materials to be used in NCR products. NCR's Manufacturing Technology Research Center is committed to the advancement of interconnect technology in support of NCR products. Properly equipped scientists are working to solve a vast number of material science problems to sustain NCR's leadership in manufacturing technologies. NCR's Manufacturing Technology Research Center, achieving the vision.